Welcome to lesson 13.3. We're just a few lessons till the very end of the trimester, so let's finish off by talking about solving quadratics. So far we've learned in Unit 13 about square roots and simplifying square roots. So we can use this idea of square roots to solve quadratic functions. So your aim today is that I can use inverse operations to solve quadratic equations. So remember how we solve normal equations? Like if I have something like y plus 2 equals 10, the inverse operation of this plus 2 would be to minus 2 on both sides, and then you solve and get 8. So this is solving using inverse operations. So that's what we're going to learn how to do, but we're going to apply it to using square roots. So now that we have a good feeling for square roots, we can use them to help us solve special types of quadratic equations, those equations involving a squared quantity. So let's make sure we understand the basic concept of undoing a square root. So exercise 1 says solve each of the following equations for the values of x. So when I see that this says x squared, remember your whole goal for solving is to get the variable alone. That's your goal here. Well, in letter A, your variable's not alone. You have a squared with it. So to undo a squared, you take the square root of both sides. So to undo a squared term, you take the root of both sides. So what's going to happen is this is going to cancel out and just leave me an x. And the square root of 16 is plus or minus a 4. So my answer is x equals 4, x equals negative 4. Okay, this is solving using inverse operations, the very basic. So for letter B, I want to get x alone, take the square root of both sides. That cancels out the squared, I'm left with just x, and I get plus or minus 10. Because the square root of 100 is either 10 or negative 10. Okay? Now this one's a little bit trickier. Okay, this one, we're still taking the square root of both sides, but when we do that, we get x equals the square root of 20. However, 20 is not a perfect square, so we have to simplify this, right? Oh, this should be plus or minus 20. So when we simplify this, we get this plus or minus the square root of 4 times the square root of 5. This is from the previous lesson. And so this 4 simplifies to a 2. And we get plus or minus 2 square root of 5 for our final answer. Okay? So the key here is that inverse operations to squaring is taking the square root. But when you do this, you always introduce both a positive and a negative answer. Squaring is a non-reversible process, meaning you can't simply undo it. Now, let's add some additional operations. Recall, we always solve equations by undoing operations in the opposite order in which they have been done. And in terms of order of operations, exponents essentially come first, so they will be undone last. So let's take a look at what that means in exercise 2. Exercise 2, we're going to practice what this looks like. Solve, this means find x, each of the following equations for all values of x by using inverse operations. In each case, your final answers will be rational numbers. Okay, so we're going to get basically whole numbers for our final answers here. Okay, so let me show you what this looks like. So I want to start solving. Pretend this x squared is just like any normal x. So the first thing I would do here is try and get x alone, so I would subtract 10 on both sides. The 10's cancel out, and I get 2x squared equals 18. Okay, the next step is divide both sides by 2 to get rid of the coefficient, and I get x squared equals 9. And in my last step, like I learned, now I can take the square root of both sides and get x equals positive 3 or negative 3, plus or minus 3. Okay, now remember this plus or minus, if you're forgetting what this plus or minus means, the plus or minus means that you've got two answers, x equals 3 or x equals negative 3. So that's what that plus or minus means. It means you have two answers. So please keep that in mind as you're solving quadratics. You usually always have two answers. Okay? All right, letter B. Same idea, a little different. Now I've got subtraction and a fraction. So I'm always going to get rid of this addition or subtraction first. So add the 5 over, those cancel out. I get x squared over 2 equals 3 plus 5 is an 8. Now to undo this fraction, remember how to undo a fraction? You have to do opposite operation, which is multiplication, because this is division. So these cancel out. I multiply the other side by 2, and I get x squared equals 16. Take the square root of both sides to get rid of that squared, and I get x equals plus or minus a 4. Okay? Now letter C is a little interesting. So C is a little interesting because normally when you guys see this parentheses squared, you want to multiply the whole thing out. But I'm going to teach you something very important here. Instead of multiplying this whole thing out, do you see how there's this little squared right here? We can undo that by taking the square root of this entire thing. That will cancel out the squared, and I'll take the square root of this as well, which leaves me with just x minus 2 equals plus or minus 5. Now, what happens here is that this is going to split off into two different problems. I'm going to have the problem that's x minus 2 equals the positive 5, and I'm going to have the x minus 2 equals negative 5. So I've got two separate problems that this splits into because of that operation that we just did. And now I'm going to solve both of these like I would normally. Add the 2 here to cancel these out. X equals 7 is my first solution. And then I'm going to add 2 here as well, but I'm going to get negative 5 plus 2 gives me a negative 3. So here, same thing, I end up with two solutions, but because of my squaring, I had to split those off into two separate equations. Okay? And we're going to take a look at this again in this next example. So this next example looks similar, except we have this minus 50, so we're going to get rid of this 50 first and add 50 to both sides. The 50s cancel out, and I'm left with 2x plus 5 squared equals 200, because 150 plus 50 is 200. Now, don't square root both sides yet. First, you're going to get rid of this 2 by dividing it away. That will get rid of the 2, because that cancels out to a 1. And I have x plus 5 squared equals 100. Now I can do the thing where I take the square root of both sides to cancel out that exponent, and I'm left with x plus 5 equals plus or minus 10. Now same thing here, I'm going to have to split this into two separate problems. The x plus 5 equals the positive 10, and the x plus 5 equals the negative 10. Then I just solve them like normal. So I'm going to subtract the 5 here and get x equals 5 because 10 minus 5 is 5. And over here I'm going to subtract the 5 to cancel it out. And negative 10 minus 5 is negative 15. Okay? So this takes us back to a little bit of solving normal equations, but adding in the idea of undoing a square root. Undoing a square is taking the square root of both sides. Okay? So if you have questions on this section, please make a note of it and then bring it to class, because there's a lot here. All these examples do something a little bit different, so please be sure you're asking for help if there's something here I explain that you're not quite sure you understand. Okay? Let's take a look at some problems that don't always come out to a whole number. Those 3 examples came out to whole numbers, which makes our work a lot easier, but what happens when it doesn't come out to a whole number? So exercise 3 has the same direction. Solve each of the following quadratics using inverse operations. Express all of your answers in simplest radical form. So we don't want to convert to decimals. We want to use what we learned in lesson 13.1, I believe, or 2, where we had the square root lesson. So let's see what I mean here. So what we're going to do is we're going to solve like we do normally here. Try and get x by itself. We get 5x squared equals 38 plus 2 is 40. Divide both sides by 5 and get x squared equals 40 divided by 5 is an 8. So now here's the tricky part. I'm going to take the square root of both sides to undo this square and get x alone, but the square root of 8 doesn't simplify to a whole number. Okay? I'm going to get plus or minus the square root of 8. So I have to simplify this square root of 8 right now. So if I remember correctly, I'm going to have to take this square root of 8, and I'm going to have to simplify it into the square root of 4 times the square root of 2. This is going to give me plus or minus. The square root of 4 becomes a positive 2, and the square root of 2 just drops down. We can't simplify that any further. Okay? Okay, so this right here is, simplest radical form. And the clue this right here, when the directions say, and it's really important for the Regents, when the directions say simplest radical form, they want you to solve it this way. They want you to use algebra and solve it using inverse operations. Okay? And you'll find too that if I were to set this equal to 0 and try and factor it, I wouldn't be able to factor it properly. Okay? Alright, sorry, I had some pen marks on there. Let me just make that clear. There we go, times. Okay? Let's try the next one. So, I want to try and get x alone like usual. These plus numbers and minus numbers are always what you want to get rid of first. Okay, so these cancel out, and I'm left with x minus 3 squared equals 38 minus 10 is a 28. Now take the square root of both sides. These cancel out, and I'm left with x minus 3 equals plus or minus the square root of 28. So now we reach that point where, now I have to split this up into two different problems. I'm going to have to split it up into the x minus 3 equals the positive square root of 28, and I'm going to have to split it up into the x minus 3 equals negative square root of 28. Okay, so you have to solve both of these. So, what's going to happen is we're going to have to simplify this 28 over here. So I'm going to leave the x minus 3 the same, and the square root of 28 is the same as the square root of 4 times the square root of 7. So when I simplify this, I'm going to get 2 square root of 7. And all I have to do now, is get that x by itself. So to get the x by itself, I'm going to add 3 to both sides. Now, with square roots, you can't actually add these numbers together. It doesn't work that way. So instead, we're just going to write our final answer as x equals 3 plus 2 square root of 7. Okay? So that's our first solution. Now we're going to do the same thing on the other side. I keep hitting these dots all over the screen. I'm not sure what. Oops. Sorry, guys. Okay, we're going to do the same thing on the other side. I'm going to add the 3 over here. Oops. Wait, no, I'm not. I'm going to wait till the end. Okay, I'm going to simplify my radical first. Now, I already simplified this radical over here. So see how I already simplified it? So all I have to do here is say, okay, I know this is actually negative 2 square root of 7. And then when I add the 3 over, you're going to see that I get x equals 3 minus 2 square root of 7. So oftentimes with radicals, you'll get like a conjugate pair. It's the exact same thing, but one's plus and one is minus. Okay? Please make notes if you're confused. This is a tricky lesson, and I really want to make sure you're feeling comfortable with it. Okay, so make notes of places where you're a little bit lost if you need help. Okay? Let's take a look at exercise 4 and see what this looks like on a graph. So far every time we've tried to find zeros, they've been in like whole number locations. But if we look here, and let's read this problem a little bit, he graphs this parabola 1/2 x squared minus 6 on the grid. He believes that the quadratic has zeros of negative 3.5 and 3.5, which if you look here, it kind of looks like it might be negative 3.5 and 3.5. It looks like it. We can't tell for sure, but it looks like it. So A says, actually find the zeros of this function in simplest radical form, and explain why Francis must be incorrect. So in order to find zeros of a function, you have to set your equation equal to 0. And we've talked about this before. That's the very first thing you have to do. So I'm going to take this right here, this equation, and I'm going to set it equal to 0. So I'm going to have 1/2 x squared minus 6, and instead of putting a y, I'm going to make it equal to 0. Because what's the y-coordinate at these 2 points? It's something comma 0, right? This coordinate is something comma 0. So that's why we want this to be 0, so then we'll figure out what our x is. So I'm going to solve this, add 6 to both sides. I get 1/2 x squared equals 6. To undo this, I'm going to multiply by 2, because that will get rid of my 1/2. And I end up getting x squared equals 12. Now I have to undo this square root, so I'll take the square of both sides and get x equals plus or minus 12. And I have to put this in simplest form. So plus or minus 12 is the same thing as saying the square root of 4 times the square root of 3. So x actually is plus or minus 2 square root of 3. Okay? So these negative 3.5 and 3.5, those are rational numbers. They can be expressed as a decimal. But this answer is irrational. Square roots are always irrational. They have decimals that go on forever and ever and ever. In fact, the next question says Francis was incorrect based on A, but was he far off? So I have x equals 2 square root of 3, and my other 0 is x equals negative 2 square root of 3. So if I actually go to my calculator, and I put this in my calculator, and I say 2 control square root of 3, and hit enter, and then I go to menu, and hit number, convert to a decimal, I get 3.4641. So when I do this, 3.4161, and x equals negative 3.4161, this is an estimate. Is he close? Are these numbers close to 3.5 and negative 3.5? Sure. He's really, really close. So it's a good estimate, but it's not actually accurate. Okay, which is why sometimes we want that simplest radical form, because this number is 100% accurate. This number, decimal, is always an approximation. Okay? So let's take a look at our final exercise for this lesson. Find the zeros of the function f of x equals x plus 4 squared minus 20 in simplest radical form. Then express them in a decimal rounded to the nearest hundredth. Alright, so I'm going to rewrite my expression. Okay, and the first thing I'm going to do is I'm going to set this equal to 0. So I'm going to rewrite this as x plus 4 squared minus 20, and I'm going to set it equal to 0. That's the very first thing. Okay, now I'm going to add 20 to both sides. Then I'm left with x plus 4 squared equals 20. Now I take the square root of both sides. That cancels out my squared, and I'm left with x plus 4 equals plus or minus 20. Okay, I got to break it up now into my two different functions. X plus 4 equals the positive square root of 20, and x plus 4 equals my negative square root of 20. Okay, the square root of 20 will simplify into the square root of 4 times the square root of 5. So I get x plus 4 actually equals 2 square root of 5. And then I subtract 4 on both sides, and I get x equals 2 square root of 5 minus 4. Okay, now for the other one, x plus 4 equals, I already figured out that my notation, my simplest form is this, so I'm not going to redo it. I'm just going to put the negative there, negative 2 square root of 5. Subtract the 4. Remember, these can't combine. That you can't just say this is negative 6 square root of 5. Square roots don't really work that way. So I'm going to say x equals negative 2 square root of 5. Let me make that a little clearer. Oops. Let me get my eraser. Alright. Negative 2 square root of 5 minus 4. So there's my answers in simplest radical form. Now I have to convert to a decimal. So to do this, I'm going to go to my calculator. Okay, and I'm going to type in control square root 5, move my cursor over 1 so I don't get that, a thing under the radical, minus 4. So that's what I put into my calculator. Oh, I forgot the 2. Alright, sorry. Let me put the 2 in front. Perfect. Okay, hit enter. That won't convert it, so I have to get to menu, number, and then convert to decimal. Hit enter, and I get 0.472. Now this wants me to round to the nearest hundredth. The hundredth is that 7 right there. So the number after the 7 is a 2, so I'm just going to leave it as 0.47. So that's my decimal approximation there, and then I have to approximate my decimal here. Let's go back to my calculator. I'm going to put in 2 square root symbol, 5. Oh, it's negative, so I got to put the negative in front. So negative 2 square root 5. Move the cursor over, minus 4. Notice that what you put in the calculator should look identical to your paper. You hit enter. It won't approximate it until you go to menu, number, convert to decimal, and hit enter. And there I get negative 8.47. So this is negative 8.47. Okay, so this is my radical form answer right here, and this is my decimal approximation form. Okay, if you have any questions, please mark them on your paper and come talk to me or Ms. Vasquez or Ms. Samaru. Good luck on your fluency.